Hello, today I'm going to be talking about gigantism and dwarfism on islands and in the deep sea. Some of the most unique environments can create some of the most unique life. Island gigantism and dwarfism is a phenomenon that has been happening long before we were here, and we can continue to see it today. There are thousands of species across many different islands that look remarkably different from their continental counterparts or ancestors. What these extreme and rapid changes in the evolution of species all comes down to is resources and predation. The island rule is the concept that on islands, species that are typically smaller become larger and species that are typically larger become smaller. This is known to be due to two major factors: access to resources and a lack of predators. With the lack of large predators on islands, due to them not being able to move as easily from the mainland or live with limited resources, smaller species can grow bigger since there isn't much of an evolutionary advantage to be small and unseen. It can also be said that having such a fluctuating environment as an island does, a larger body can travel longer distances for the scarce resources, as well as last longer without food and water. Birds of prey on islands evolved to be larger instead of smaller because their food source is the typically smaller animals that then have grown to be larger. Another reason for these extreme changes in body size is filling niches that are typically filled by other animals not found on islands. With a lack of resources on an island, larger species tend to be smaller to be able to sustain themselves. You can see this effect more so on smaller and more remote islands due to the extremity of these conditions that I've talked about. Smaller species are able to evolve to be much larger from the lack of predators they have, and larger species must downsize due to the lack of resources to sustain how large their ancestors are. Smaller species like rodents already don't need a lot of resources. They have the capacity on an island to evolve to be larger because they aren't being preyed on as often. There are many examples of this effect taking place. One well-known example is the giant tortoises found in the Galapagos. This is thought to be because being larger enables them to travel longer distances for resources and to live longer without food and water, like I mentioned before. This is needed in the fluctuating and unpredictable conditions of an island. Other species exhibiting gigantism are the field mice of St. Kilda, giant pill bugs on Madagascar, giant shrews, elephant birds, and dodos. All of these species evolved to their size from the lack of large predators and unpredictability of resources. Dwarfism is seen in species like dwarf elephants, pygmy mammoths, dwarf chameleons, and Homo floresiensis. With these animals, the lack of large predators means that they don't have to be as large as their continental ancestors, and they evolve to be smaller since there aren't as many resources on an island to support larger creatures. Homo floresiensis is an ancient hominin only found on the island of Flores. They were under 4 feet tall and hunted the giant rats on the island that evolved also due to the island effect. They are proven to have used stone tools and fire, which is seemingly advanced for their cranial capacity. Some say that Homo floresiensis evolved to be small from another hominin ancestor like Homo erectus after they traveled to Flores, while others are looking into the idea that they may have already been small when they arrived there. There are also theories that they had a disease or disorder that made them small. Knowing what I do about the island effect, I'd say that it's most likely they evolved to be smaller due to the conditions of the island. However, I'm not sure if they evolved from something as large as Homo erectus was, or maybe a smaller hominin. Now looking at another example of gigantism not entirely related to islands, deep sea gigantism. This is a phenomenon characterized by creatures in the deep sea growing much larger than their counterparts in shallower depths, and it mostly affects invertebrates. The reason that these creatures can physically become so large is because of their buoyancy, creating less force downward by gravity, meaning that the animals won't collapse under their own weight. There are multiple theories on why this happens, however. The two main ideas are Kleber's rule and Bergmann's rule. Kleber's rule is the idea that larger animals are more efficient in the deep sea. Being larger creates a slower metabolic rate, and since food is so scarce that deep, they need to conserve as much energy as possible. The only food source that those animals have is the scraps of food and waste from mostly shallower waters, called marine snow. Animals that exhibit the evolution from Kleber's rule include the hadal amphipod, that lives over 10,000 meters deep. It uses enzymes to digest wood and other difficult-to-digest materials from the seafloor like dead plants and animals. These animals are crucial to the ecosystem as they get rid of all the materials that other animals can't digest while also excreting organic matter that other animals can get nutrients from. Another amphipod is the supergiant amphipod. It has evolved to fill a niche typically filled by crabs in shallower waters, since crabs can't survive so deep. The big-finned squid is a well-known deep-sea giant whose tentacles stretch down to feed on organisms deeper while they hide in the darkness above. An animal that shows Kleber's rule especially well is the Greenland shark. They are very large, meaning they can store more food and travel longer distances while conserving energy. The slow metabolism of these marine animals allows them to live immense lifespans, with some Greenland sharks living over 300 years. Kleber's rule makes sense for vertebrates and other animals that are mobile and must travel or hunt for their food. However, thinking about things like sponges and corals, Bergmann's rule makes more sense. Bergmann's rule is the idea that deep-sea gigantism comes from the lower temperatures. This is supported by the fact that most gigantism is found in colder polar regions. In such polar regions like the Arctic, even animals in shallower depths are much bigger, grow slower, and live longer. These regions are also often isolated by currents, and that keeps their environment stable and oxygen-rich. This goes along with the oxygen temperature hypothesis. Since cold water holds more dissolved oxygen, the animals in polar regions have a huge abundance of oxygen. The amount of oxygen they have access to leaves these invertebrates with a lot less size constraints, and they can grow much larger. There also aren't many fish in polar regions. After learning about this, I was wondering how these invertebrates survived and thrived being so big in an area with so little nutrients but so much oxygen. Many animals in polar regions use a process called chemosynthesis to produce food, where they use the energy from inorganic chemical reactions to get their nutrients and make organic matter. After analyzing these two rules, it seems possible to me that they both can be true. Kleber's rule applies more to mobile animals in the deep sea that need to travel long distances for their scarce food and therefore need a slower metabolism and larger size. Bergmann's rule applies more to the relatively stationary organisms that live in very cold waters or the deep sea, where the oxygen-rich environment there allows them to grow as large as they can. Climate change has a profound effect on deep-sea gigantism and ecosystems. As the water warms and sea levels rise, there is less oxygen available in these colder regions. This is extremely detrimental to the species that live there. The isolation and currents of polar regions are also disturbed with the warming and allow for invasive species and new predators to survive in these places. This disrupts the entire ecosystem that has been created and thriving for many years. Climate change is making it more difficult for deep-sea giants and giants in polar regions to survive. There are similarities between deep-sea gigantism and island gigantism, such as the fact that scarce resources is the reason for it to happen. However, despite this similarity, the fact that the deep sea is unimaginably vast and islands are far more constrained than continents is a huge difference. It's amazing that these phenomena are observed in such different circumstances, yet for the same reasons, and both are isolated in their own ways. Extreme changes in size all result to that isolation, which creates limited resources, different biodiversity, and different physical environments. All of these things are interconnected. The limited amount of resources and extreme environments contributes to the very different biodiversity than shallower waters or continents. Overall, the unique conditions created by islands in the deep sea are perfect for evolving to extreme sizes and can be observed all over the world.